ladies and gentlemen, so we have been talking about slope-intercept form of our equation, which remember is this y equals mx plus b, where m is the slope and b is the y-intercept. So we've been talking about that for the past couple of weeks, and we are going to end our year by talking about how to write an equation in this form. And really all you need to write an equation in slope-intercept form is you need the slope and you need the y-intercept. Everything else will stay the same, but your numbers for m and b will change. So let's look at a couple of examples. We want to write an equation that represents a situation. So we want to write the equation in slope-intercept form. Well, letter A says that m, the slope m, is -5 and the y-intercept b is 3. So they gave us those values, and all we need to do is write them in our equation. So our y equals m times x plus our b value. Notice how compared to our slope-intercept form, everything stayed the same except for m and b. That's how you write an equation in slope-intercept form. You just plug in the slope for m and you substitute in the y-intercept for b. That's all you need to do. So looking at letter B, the slope m is 1/2 and the y-intercept b is equal to 0. Well, we would have y equals 1/2 x plus 0. Plus 0 doesn't really add anything, so we could write plus 0, or we could just leave it as y equals 1/2 x. Looking at letter C, m is 2 and the y-intercept is -9. So we'll have y equals 2x, and then instead of plus 9, I'm going to put -9. If you put plus a -9, that would be fine as well. They are the same thing. Plus a -9 and -9 mean the same thing. How about you pause and see if you can do letter D. M is 0 and b is 6. So if you had y equals 0x plus 6. But what is 0x? What does 0 times x really equal? Well, 0 times anything is really 0, so we could also write y equals 0x plus 6 is just y equals 6. And that's how you write an equation in slope-intercept form. Again, really important to remember that all you need in order to do this is the m value and the b value. Now we're going to try and write it from a table. So we need to look at our tables to find our slope and our y-intercept, and then we'll be able to write our equation. So looking at letter A, I'm going to start with my slope. So remember, I need to figure out my pattern. So to get from -5 to -4, I'm adding 1. To get from -4 to -3, I'm adding 1. -3 to -2, I'm adding 1. So my y, I'm adding 1. Remember, our slope is y over x, so we're adding 1 for our change in y. And then for our change in x, well, from -4 to -2, we add 2. From -2 to 0, we add 2. From 0 to 2, we add 2. From 2 to 4, we add 2. So our slope is changing y. Our change in y is +1. Our change in x is +2. So our slope is 1/2. That's easy for me to say. And then for our y-intercept, we're just looking for where x is 0. Well, here x is 0, so our y-intercept is -3. Which leaves us with the equation y equals 1/2 times x minus 3. Looking at our next table, we're going to do the same thing. We'll start off by finding our change in y. It looks like we're adding 1 each time for our change in y. For our change in x, it looks like we are also adding 1. So our slope would be +1 over +1, our change in y over our change in x. Well, 1 over 1 is really just equal to 1, so our slope we could just say is 1. Notice how 0 isn't actually in our table, which means we need to find it. So here's -2, then we'd go to -1, then we'd get to 0. So we need to mirror that change on the other side. So 5 plus 1 would be 6, 6 plus 1 would be 7. So when x is 0, y is 7. That's our y-intercept. So our equation is y equals 1x plus 7. Or you could write this as y equals x plus 7. And that's your equation. So we got a couple more. Now we want to be able to look at a graph and write the slope-intercept form of the line. So for our slope, we're going to pick 2 points and figure out the distance between them. So here's a point and here's a point on my graph. Looks like we go down 1 and over 1. So our change in y would be down 1. Our change in x would be +1. Well, -1 divided by positive 1 is just negative 1. So that's our slope. And then our y-intercept crosses it right here, and that is where y is negative 1. So our equation will be y equals negative 1x minus 1. It'd be a good idea to pause and try a couple of these next ones. So again, I'm going to pick points, and I'm going to make sure they're nice points. So I'm going to make sure they're crossing, so I'm going to pick this point, which actually happens to be the y-intercept. So we know our y-intercept is 2, and it looks like our next nice point, boy, is all the way down here, isn't it? So we have to go up 1, 2, 3, 4. 1, 2, 3, 4, 5, pardon me, 6, 7. So up 7, so our change in y, over 1, 2, 3. And then our change in x is 3. So our slope would be 7 over 3. So our equation is y equals 7/3 x plus 2. And that would be our equation. All right, letter C. Well, looking at it, for our change in y, we go up 1 and over 0. Well, 1 over 0, what is 1 divided by 0? Hopefully that sets off alarm bells because we cannot divide by 0. So this is undefined because we cannot divide by 0. And looking at our y-intercept, our graph does not cross our y-axis at all. And so for our y-intercept, we have none. And what that means is that this is going to be x equals something. Okay, this is a special case of a vertical line, so x equals what? Well, if we're looking at our line, no matter where it is on the line, what's the x value? This is the point negative 4, 4. This is the point negative 4, 2. This is the point negative 4, 0. This is the point negative 4, negative 2. So notice that those y values are changing, but the x value is always negative 4. So this is the line where x equals negative 4, and that'd be our answer. Last but not least, letter D. So again, I'm going to start with my point. Here's a nice point. That's also our y-intercept. So our y-intercept is a positive 1. And then to get to, here's another nice point. We're going to go down 1. So our change in y is negative 1. And over 1, 2, 3, 4. So our slope will be negative 1/4. So our equation is y equals negative 1/4 times x plus 1. And that's how we write our equations in slope-intercept form. It's like my document's freaking out. Here are a couple more examples. Looking at letter E, we have the special case of a horizontal line. So for our slope, we don't go up or down at all, and then over 1. So we'd have 0 over 1. Well, 0 divided by 1 is just 0. So remember, whenever it's that horizontal line, your slope is going to be 0. And for this one, our y-intercept is right here where y is 1. So we could write our equation as y equals 0 times x plus 1, or we could just write it as y equals 1. Either of those will work. This is the one you'll see most often. Letter F, well, see, our y-intercept is way up here, so that would be the point where y is 3, and then to find another nice point on our graph, it looks like, remember, it's got to be going exactly through it. So some of these are pretty close, but they're, right, this isn't exactly on the point, and so that's why we have to be careful when we are choosing our points. I'm going to pick this one. So we're going to go up 1, 2, 3, 4, 5, 6, 7, 8. Up 8 over 1, 2, 3, 4, 5. Up 8 over 5. So 8 over 5 would be our slope, which leaves us with the equation y equals 8 over 5 times x plus 3. And that is how you write equations from a graph. So for your homework, you're going to do that same thing. Write your equations from your words, from your table, and from your graphs, and that's your job. For some of these ones where the 0 isn't in the table, remember you have to find 0. So for number 11, you'll have to find the y-intercept when x is 0. For number 10, you'll have to go backwards to find the y-intercept when x is 0. Okay. Number 8 is the only one where the y-intercept is directly given to you. The other ones you have to use the slope to find it. All right.